Have you ever been playing a multiplayer game, lining up someone in your sights, and then they teleport away? Lag in video games sucks. What is it though, and can I safely blame my performance on it? Today, we're gonna look at why it happens, how it happens, and what we can do about it. Hey everyone, welcome back to the channel. If you're new here, then my name is Lewis, and I'm on a mission to inspire developers and tech enthusiasts. In order to understand what lag is, we first have to understand how online games even work in the first place. In general, it involves two parts, client and server. This setup consists of a dedicated server in a data center somewhere. This server is the central point for all clients, or gamers, to connect to. And it connects with a protocol called User Diagram Protocol, or UDP for short. This connection is different from something like TCP, which is used to connect to a website. Because of the speed and fast delivery rate, we can understand the role the servers play with this quick example. Let's say we're in a game and spot an enemy. To assert dominance, we need to move our character to the right. If we're at position 10x, 10y on the map, by hitting the right button, the client then pings the server the position of our new location, 11x, 10y. And then the server has to relay our new position back to everyone's client in the game, which then displays our new position on the screen. Success! We move to the right. And we're not talking about turn-based games here either. This lengthy process is happening many times per second for everyone involved in our game. Think about a battle royale game like Fortnite or PUBG, where there could be up to 100 players in one match. The server is working to parse every player's or client's input, the damage they do to the terrain, and items they receive from the server in order to keep things updated in real time. However, and it's a big however, we have to take ping into account. Now, ping can be defined as packet internet or internetwork groper, a fancy name, I know. But what does it mean? Well, are you familiar with bats? Okay, sorry. Please don't click off the video. Bats use echolocation in order to navigate their surroundings and find other bats. They do this by emitting high-frequency sound waves through their nose or mouth, and then they listen for the echo. When they receive the echo back, they can determine both where they are and where their target is. Well, ping works in a very similar way. The client sends out an ICMP, or Internet Control Message Protocol, echo request to a specific address, usually the server. Then the server responds by sending an echo reply packet. And this has two purposes. By sending and receiving the ping, we can determine whether the recipient is available and can determine how long the process takes, or round trip time, RTT. Usually the server will be pinged a couple of times and then we'll display the result. I've been saying this for years, but the internet is just bats controlled by humans. Debate me in the comments. I'm not scared to argue. Now let's get a bit technical. Suppose you're logged in at London, UK, and you're connecting to a server in Paris. That physical distance is 342 kilometers. So how fast does our information travel? Well, pretty much the speed of light, which is like 300,000 kilometers per second or something. So if you did the math, in an ideal world, our input would take 1 millisecond. Wow, that's pretty fast. Okay, but let's rejig the example and say you're instead connecting to a server in Tokyo. The distance this time is around 9,500 kilometers from London. So if we did the math again, our input would take 31 millisecond. Wow, that's also extremely fast. Okay, if this was true, this video wouldn't even be here. In the real world, data often has to pass through a bunch of different jumps to get to its destination and back. Routers, ISPs, and network conditions can add on to the response time. So for instance, our connection to Paris might actually end up taking anywhere between 50 to 100 milliseconds, and our connection to Tokyo might take anywhere between 300 and 1,000 milliseconds. Okay, but how does this affect our gaming experience? Think about the gamers, people. The team over at Respawn released an article about their popular battle royale game, Apex Legends, explaining all the ways the game can be affected by this particular infrastructure. So in the late summer of 2020, the dev team implemented this information panel into their game UI. As you can see, it displays frames per second, how fast your screen updates per second, connection latency, as well as these 4 other variables: in, out, loss, and choke. In and out measure the bandwidth consumed by the game in kilobytes per second, and loss and choke refer to the percentage of packets that fail to arrive at their destination. This data allows the dev team to quickly identify potential issues, which speeds up the repair process. So here are some of the issues that they faced, as well as some of the ways that they've dealt with it. Bear in mind that this is probably applicable to other titles like Call of Duty Warzone, Fortnite, Overwatch, Valorant, CSGO, PUBG 3D, slow motion server. I'm sure we've all experienced this one. Sometimes every single player in the game is lagging and everything seems to be running in slow motion. Well, this is actually caused by faulty hardware on the server. Typically, the server updates the game with its information from the clients at 50 milliseconds or 20 times per second. If the server takes longer than this for whatever reason, the game itself will run slowly in order to account for the delay. Thus, slow motion servers. Though this can be caused by several things, it's mostly linked to issues like underclocked CPUs at the data center, network congestion, or overheating that degrades the data center's performance. It also means the game companies can blame everybody but themselves. Up and down latency. This is also known as crazy ping. See it, it's angry, see those eyebrows? That ping's pretty crazy. This is where player ping can increase and decrease rapidly, causing all sorts of fun displays on the screen. There are two key culprits. Either you're playing over a Wi-Fi connection, in which case Godspeed, or the server is being degraded due to things like the physics engine or ballistic calculations. For instance, the dev team highlight their own experiences here. In Season 7 and 8 of Apex Legends, they had an issue where the game would slow down dramatically on the character select screen. It turned out to be caused by player models spawning in off screen and overlapping each other before moving to the dropship. The physics engine just did not like this at all. So even though all this computation was happening off screen, it was causing massive CPU spikes in the server, which meant latency issue for the clients. Packet loss and packet choke. All right. This one is a little tougher. Remember a few minutes ago when we were discussing the jumps or hops that data had to travel through to get to its destination? Yeah, surprise, surprise. Let's imagine this pathway again. Your client, your ISP, hop 1, hop 2, hop 3, data center. Now, issues can appear literally anywhere along this line. It's literally like track and field blindfolded with hurdles placed randomly. Maybe your ISP is having an issue of their own and this is impairing your ability to send data. Maybe hop 1, 2, or 3 are having issues. Maybe it's all of them. And if that wasn't bad enough, the data has to come back to you after it's been to the data center. So data center, hop 4, hop 5, hop 6, your ISP, your client. It's very easy to see that this is a very hard problem to diagnose, especially considering that the data's return trip might not even pass through the same hops as it did on its journey there. These problems are hard to diagnose as it could be any number of issues along these two pathways. But even when you can identify the troublemaker or the troublemakers, it might take time to implement the fix. It could involve contacting third parties, negotiating with ISPs, or changing the pathway in its entirety. So the dev team is confident that this issue will be fixed through automation, but it's still in its early stages. The good news though is that this is usually a group issue, so a fix for one player could probably be a fix for many players. This is where you start hitting up the forums. Dying behind cover. Shooter games often rely on cover as a core mechanic, encouraging players to find safe spots between objects where they can avoid gunfire. I'm sure this fact was very thought-provoking. So when players get killed directly through these boundaries, well, gamer rage happens. In the dev's own words, this is a spicy topic. The problem arises from a sneaky bit of technology, and that is trying to simulate a real-time game state. As we've already established, the server receives client input, calculates and updates the game state, and then sends it back to the client. Great, but what happens when one client receives the game state faster than the other? Or slower? Good question. The key thing to remember is that there's no one truth or perfect solution to this. So with that in mind, here's a good breakdown of the issue. Imagine a scenario where you have two players, Lewis and Will. Let's say Lewis has a ping of 50 milliseconds and Will has a ping of 300 milliseconds. Both players have entered the game and encountered each other. They both have the same weapon and shoot each other at exactly the same time. But what happens? Well, because Lewis has a ping of 50 milliseconds, their input will reach the server first. It just travels there faster. Will's shot will reach the server 250 milliseconds later. And remember, the server updates every 50 milliseconds, so that means that the server will register Lewis's input 5 updates before it registers Will's. This means that the server will register Lewis's input 5 updates before it registers Will input, meaning that Lewis will shoot first even though their input was simultaneous. The result, Lewis kills Will normally from their perspective, whereas Will dies before they even know what happened. A pretty gross experience. Let's imagine a second scenario now. Lewis, 50 milliseconds, rounds a corner and encounters Will, 300 milliseconds. I'm sorry, Will, but your internet is being laughed at here. Because of the Lewis updates coming much quicker, they spot Will's 250 millisecond faster than Will spots them. This combined with the fact that Lewis's input to shoot will arrive and come back faster, meaning Will is dead once again. All right, third scenario. Will, 300 milliseconds, is chasing Lewis, 50 milliseconds. Lewis gets into cover to protect themselves from Will's bullets. However, Lewis still gets shot and dies. What? In this instance, because Will's updates come slower, Will can still see Lewis and shoots them. Because Lewis's updates comes faster, they're behind cover from their perspective. But by the time Will's packets arrive at the server, detailing the shot, the damage, etc., it doesn't matter that Lewis was behind cover on their version. Will was more into the past, and so the server registers damage slower, meaning that Lewis dies anyway, even though it looks like they were safe from their perspective. It's a little bit complicated, but it's annoying for both parties. Well, mostly me. Both Lewis and Will, due to that 250 millisecond difference that they have, both experience nonsense in some way or the other. So dev teams are often working hard to find ways to combat this, but sadly, it's just a matter of latency variation, which can really only be fixed in places like your LAN settings. My solution is to just ban everyone that has a ping higher than 20. Okay, everyone else was thinking it, okay? Gunshots not registering damage. Similar to our situation with Lewis and Will, sometimes ballistic systems can go pretty crazy. This has to do with hit registration. Occasionally you encounter a no reg or no registration. Basically, you fire your weapon and you get a visual and audio feedback confirming the hit, but no damage or kill. In this instance, the server basically just disagrees with you and you really can't argue with the server. Let's go back to Lewis and Will. Lewis has 50 milliseconds and Will has 300 milliseconds. Will shoots Lewis, but Lewis jukes to the left. Lewis dodges the shots from their perspective, and because their game state is updated faster thanks to their lower ping, that's what they see. But from Will's perspective, Lewis hasn't moved yet. The bullet flies through the air, hits Lewis's player model, they look like they got blasted, but no damage. The server recognized Lewis's position thanks to their faster ping, and when it gets Will's information a little later, it disagrees that Lewis was even there to be shot at, let alone take damage. The dev team explained that this can be sometimes caused by bugs in the ballistic computation, but it can also be caused by things like bullet size. Some bullets, aka sniper rounds, are physically larger than SMG bullets, for instance. This could also be a result of the code that's on the network that helps prevent cheaters from hacking the game. If I can go into the network and put code in there that basically spawns you right in front of me, well, the game won't be any fun now, would it? Some internal software that's made to detect these types of bugs can only be run on development servers. So it's very important that you report these types of things so that the dev team can know about it. Thanks to Rickle Saucer from the Apex Legend team for posting an in-depth article and for providing that vulnerability to both software engineers and gamers, two groups I'm deeply scared of. Similarly, information like this will maybe help reduce player frustration. It's not fun to lose to a game due to laggy conditions or janky interactions, but understanding the problem is the first step you have to take in order to get a proper solution. That sounds like an AA meeting. I love diving deep into video games, so make sure you check out my video on how some random programmer took Grand Theft Auto online from like a 10-minute wait time to like a 2-minute wait time. Let me know in the comments what you want to see, and check out the Discord community that I have with over 9,000 other developers in the comments below.